So there's one, so that's ionization energy. There's a related concept here, which is electron affinity. It's the opposite process of ionization energy. And it's important. It's not the reverse of the process. The reverse of the process would be how much a single, a atom plus likes an electron. That is the reverse of the ionization energy. The electron affinity is going in the opposite direction, taking a neutral atom and seeing how much it likes to have another electron. And so what we see, interestingly enough, is that we actually, most elements wouldn't mind having another electron. Some really want another electron. Some are, essentially zero. For example, helium and beryllium, the noble gases, there's no additional gain for getting an additional electron. Sodium actually wouldn't mind having an extra electron, right? It's going to get another a 2s electron to go on with its first one. That's not so bad. So the electron affinities are generally negative because they're either zero or they're a little bit negative. So what all of this seems to be shaping towards is some general principles, as you've probably heard before, the octet rule. And the octet rule really is just a restatement that it's most stable to have things with a configuration that's like a noble gas configuration. So the group on 1A, it's easy to lose 1s electrons because that gives you a noble gas configuration. Group 2A, it's easy to lose 2s electrons. That's not a 2s electron, that's 2s electrons. That gives you a noble gas configuration. It's not trivial. You still have to strip those away. The ionization energy is still non-negligible, but it's relatively easy. Group 7, it's pretty easy to gain 1p electron to get up to a noble gas configuration. Group 8A doesn't like to gain or lose electrons. It already has that relatively stable electron. In order to change from that, it would have to lose one of the p electrons, and that's hard to pull off because you have that you're losing. It would be the last electron to complete a shell, so you have a lot of positive charge pulling that in. And it doesn't like to gain it either because you'd have an extra electron that would be in a next shell out, and that next shell out is just not nearly as attractive as the current shell. So that we can see that this octet rule comes down to general principles focused around the orbitals and the energy levels of the orbitals.